Hello everyone, so today I will show a Grasshopper script that can randomly generate, create, and also rotate boxes. So to maximize the intersection volume. And okay, here we go. Um, Here's a site, and here's a Grasshopper script we'll be talking about today, and here is the final result. Okay, so we have the site, and everything will start from this rectangle on the site. We will be doing something that will offset the site to a smaller triangle on the one direction, and also array box them into to make different floors. And what you have to do is you have to actually make a box and then plug this into the count and also how many floor numbers you want. Yeah, that's a count. And what we also want to do we want this geometries to be tapered at the top. So we create this range from 0.5 to 1, and as you can see, create this. It should be it should be 0.5 to 1. So you can see you have this file. So at the top, it will be actually have the range. The region will be actually have the size of the one at the bottom, and then we'll be plug them into the geometries we just generated by using array box, and then another important thing is that populate 2D. What this do is that it will grab all these regions, and then you will give a random list of how many numbers you want to be popped at each floor. In this case, we want it to be either 1 or 2, and then since we have 10 floors, and we will then in the end have a list of with 10 items that shows each floor how many boxes will be generated. And here we will have our point. This will be the center of the boxes that will be generated. And for the box, as you can tell, we have control for both of the, we have like input for both of the X, Y, Z. And as you can see, I set up the width as a randomness from 8 to 15, then from 20 to 40, and then height from 9 to 11. And all these are randomly generated, and then they will be plugged. Also for width and length, I stored them, so they will be bigger at the bottom and smaller at the top. As you can see, all the boxes is generated right now, and here, since we have a C that is controlling the randomness of the population 2D, we can just change it, and then it will change the box arrangement. Here we have all the boxes, and what we want to do now is to use a lunchbox command that's called split random, random split. And then this similarly as the random we used before, but you can split a group of geometry into 2 groups. As you can see, I want the box into 3 groups, so I will be splitting them once again. You set up the ratio that you want it to be split, and then you split another time. So this will be like more or less the 3 equal group. And I want the first group to be boxes that stay still, they don't rotate. The second group that rotates vertically, and then the third group that rotate horizontally, just to give diversity. And here we have our another randomness, and then the angle will be from negative 45 to positive 45, and then you have to change it from angles to radius, and then you will, as you can see, here are some negative ones, some positive one, and then you plug this into 3D, rotates 3D, and here's the input of geometry, here's the angle, and here is the center. You know how to get that using this box command. And then the X will be, since this one is rotating horizontally, so the axis will be actually the Z unit. And same for the one that rotate vertically, you will put x unit as the rotation. And now we have all of our boxes, and how we want to optimize is that we want to maximize the intersection volume. So from a design perspective, this will allow the most possibility for interior circulation connection. And how we did that is that we union everything and calculate the volume of that geometry, and then we also calculate use max adduction, calculate all the boxes volume individual and then add them together. So if we use the max adduction to minus the volume from the Boolean union BRIP, we will get this number, and we want the intersection number to be as big as possible. This is how you plug into Galapagos. We want it to be maximized. And also, there are 3 seed we plugged in. The one that determines the split, the randomness split. Also, the one determines the angles. The last one determines the random point population, as you can see. Okay, so that's it. And after you run the Galapagos, find the most optimized solution, reinstate it, and then we will have the geometry ready for wrapping. Thank you.